Okay, I think we're all ready now to start. So I'd like to welcome the delegates who are joining us today. I don't know if you've done any of these Q&A sessions before, but basically the objective is to enable you to put questions to people who have spoken in the Congress and to ask them to expand on some of the material they provided and possibly even stuff which they didn't. So the format is that we will have a number of questions, some of which have been previously submitted, which our lecturer will answer during the next half hour, and then we'll go away and you'll be able to access this material afterwards through the Facebook page and also through the link which will be provided by WebinarVet. So welcome, and I'll start off by introducing our lecturer. So Dr. Scott Carver, welcome Scott.
Thank you, it's great to be here.
Scott is Senior Lecturer in Wildlife Ecology at the University of Tasmania. He's Chair of the Wildlife Disease Association of Australia, and he's State Representative for the Australian Society for Parasitology. His research interests are currently focused on wildlife disease ecology and epidemiology, and wildlife disease control using a combination of field research, laboratory studies, and modeling. In WCVD9, he lectured in the program on skin diseases of wildlife and exotic animals, with a focus on his current main research interest, which is management of sarcoptic mange in wombats. I'm sure that most of you will already have listened to this very informative and entertaining lecture. Scott's research has also covered a number of other areas, including mosquitoes as vectors of Ross River virus in Western Australia, the worrying impact of chytridiomycosis, an emerging fungal skin disease in frogs and other amphibians, which he studied in New Zealand, and transmission of viruses and other pathogens amongst small mammals in the United States. Some really exciting research. I wish we had longer to talk about it. We've also had other material in the Congress from Tasmania, which I hope delegates you will have seen, and this is the progress which has been made on attempts to control the Tasmanian devil facial tumor disease. And this is presented by Professor Catherine Belov, also in the Exotic Animal Program of the Congress. So I do encourage you to have a look at that if you haven't already done so. So we're very grateful to you, Scott, for your willingness to respond to the questions in this Q&A session. Delegates, you can submit additional questions if you wish, using the Q&A button, which you'll find at the bottom of your screen. When you click on that, please enter your question and indicate where you are located, because that helps us to determine who's asking, where they come from, and what their interests may be. So please do that. We already have a number of questions, and I will try to incorporate any new questions within the ones we have, or pose new questions if appropriate. So we have up until half past the hour to do this, and I know we're going to have a very interesting session. So Scott, are you ready to go?
I am ready.
Jolly good. So the first question is, what do we know about the introduction of Sarcoptes scabiei to Australia?
Well, thanks, David. I'll be the first to confess that sarcoptic mange has become my sort of passion for diseases and wildlife. While I've worked on lots of different ones at this point, there's one that I sort of spend a lot of my time thinking about and working on with a really great team of students at the moment. And I find this such a fascinating disease because it's, well, globally distributed, is arguably one of the widest host species range for a mammalian parasite. We'll soon have a publication out suggesting that it's been documented in 148 species of mammal to date. So, and that number is still growing. And it's got such fascinating origins that potentially look like they might have been European origins, potentially even human origins. It certainly looks like humans and their domesticated animals. And we've seen sort of really interesting patterns in Australia where, from all intents and purposes, we consider it an invasive parasitic disease of mammals, but introduced quite a long time ago. And there's quite good records of its historic sort of entry into Australia, and that really comes from ship's doctors on convict ships, where they would actually record convicts that had scabies, which I find a really fascinating sort of element of sort of incorporating that sort of European colonial history in Australia to potentially other diseases. And really early on in those colonial times, people were also bringing dogs, and dogs were in Australia, particularly in Tasmania, more important than guns for hunting and people being able to have subsistence off the land. So dogs could quite easily go and catch a kangaroo or an emu around Hobart or other places in Tasmania. And I suspect it was likely through the interaction of dogs with wildlife, and in particular wombats, that you saw exposure of mange mites and cross-species transmission that ultimately has led to establishment. And we've done a bit of work in my lab over a few papers where we've tried to look at sort of the genetic sort of structure of Sarcoptes scabii mites from different animals around Australia. And ultimately our sort of conclusion is that it's sort of more or less kind of a panmictic sort of population of these mites, and that's not really very different between different, whether it's a koala or a wombat or a dingo or something else, or even an invasive fox in Australia. And it looks like, if you look at sort of just haplotypes, that it might have been multiple introduction events, which I think really sort of fits with the sort of colonial sort of introductions. So it's a really fascinating history, and we think it was probably introduced. We know we've got convict records dating back 200 years in Australia, and in wombats records at least 100 years, and probably longer than that.
Wow, that's really fascinating. How long would the ships have taken to get to Australia from the UK, for instance?
Oh, that's a good question. I'm not sure I know the answer, but I think it's probably like 1 or 2 months. Wow. So probably not a very pleasant journey if you're a convict either. So.
And I guess that the sarcoptic mange amongst the prisoners would have spread throughout all of them, I guess.
Yeah, it was common. I've seen some of the records from the boats, and it was quite common for the doctors to actually diagnose scabies on these ships. I'm not sure that it's ever actually been published. It's something that I've been wanting to pursue, and actually I've always thought it'd be really great to have some students that sort of talked about sort of that historical epidemiology of that sort of disease invasion, because I think it's just such a fascinating story.
It's an amazing, what a parasite. I mean, 148 species, that's quite something. We could go on.
Growing.
We do have more questions, so I think let's move on to the next one, which is the first few questions are all pretty much related. What is the significance of sarcoptic mange to wombat conservation?
So this is quite a big question that is relatively controversial in Australia. So being an invasive pathogen, occasionally you see these sort of massive outbreaks in wombat populations, and you will actually see local population declines. And we documented one that declined over about a 6-year period by over 95%, which is huge. But it's and we sort of documented it moving through this population as this sort of very slow moving wave. So it took 6 years to move about 1.5 km or 2 kilometres. So it's not very far. We think it's because wombats sort of move it from one another via their burrows, which they switch periodically. Otherwise, wombats are quite solitary animals. But that seems to be the exception. We're gaining a greater appreciation of quite varying epidemiology. So we see cases where it seems to persist in populations, and we don't see any real population decline, and we see maybe 8 to 10% prevalence. We've done some modelling that suggests under a range of sort of scenarios, you can see disease persistence in populations where you're not seeing major declines. And some modelling that we've done suggests that you can get sort of 4 epidemiologically stable states. One of them is that everybody dies, which mathematically is stable, but I don't think any biologist would call that stable. There's one where you get persistence at varying prevalences. There's one where you get the mite dies out and the host survive, which probably happens in drier climates where the mite doesn't survive so well off the host, and one where you get sort of these sort of fluctuating stable sort of epidemic cycles. And it also impacts other animals like koalas, but we sort of see steady cases in koalas, which is sort of a weird animal to get exposed to Sarcoptes mites, because koalas are not that social either. And we think that might actually be more cross-species transmission from foxes, which are of course invasive in Australia, and they get mange. And we think that they rub themselves up against trees, and koalas probably get exposed when they're climbing up and down trees to source water, among other things.
That's really interesting. We see parasitic infestations in laboratory animals, which will become almost subclinical, and then when the animals are stressed, suddenly they pop out again. Are other small mammals involved? Well, actually, I better not get onto that, but because there's another question which I think I want to ask first, and that is to do with susceptibility. Why is it, do you think, that the wombats and also the koalas seem so susceptible to this disease?
Yeah, it's a great question, and it has been a perpetual sort of question that we don't have a good answer to. They're kind of susceptible to the worst form of mange as well, so they will get crusted mange. And we're still trying to figure out if there's even any real resistance in wombats. It's never been tested before. I have a student at the moment who's going to just start trying to look for antibodies in wombats where we've got endemic disease, to see if we can sort of see any signs that we've got individuals that are obviously getting exposed and recovering, but not developing clinical signs. Wombats and koalas have really low metabolic rates. So wombats, their metabolic rate is about 70% that of a kangaroo, and sort of 50 to 60% that of most sort of ungulates. So they're really low metabolic rates. Koalas are quite similar. We think maybe that has some immunological relevance. What exactly that is, I'm not 100% certain. But they are incredibly susceptible. We see mange occasionally in a few other species in Australia pop up in addition to things like invasive ones like foxes. But it doesn't seem to persist in them nearly to the same degree.
That's really interesting, because listening to Catherine Belov's lecture, she was talking about immunity and immune function amongst the Tasmanian devils, and showed that there was a big difference in immunity between different species. And I believe this is the control system that she's trying to establish, is to get more high immunity.
Yeah, and devils use wombat burrows as well. But we've never documented a Tasmanian devil with Sarcoptes. They do have their own mite. I can't remember what that one is just off the top of my head. And as they get older, they start to look a little bit mangy, but that actually isn't caused by that. Devils. But we've never documented it in there. I've always been a little bit sort of surprised by that. Maybe devils just have, when it comes to those sort of ectoparasitic infections like mite infections, they're maybe a little bit better at resisting it. I'm really not certain.
Is it possible that their prey doesn't generally have sarcoptic mange?
I think it's probably less to do with prey, more to do with exposure. So it pops up occasionally in swamp wallabies that live in sort of wet areas, and will actually kind of like stick their head down wombat burrows. And we think that it's really the burrow environment is the site of transmission, and that's why it can persist in wombats. And foxes will use wombat burrows, and they may pick it up that way and also move it around a bit as well. And occasionally you see it in Western Australia. It's popped up in like southern brown bandicoots, which they call quenda out there, and the Aboriginal name for those. And it's ecologically quite similar, live in sort of not necessarily burrows, but in sort of, in hollows or in sort of like dampish, coolish environments where the mite survives for a bit longer. There's better opportunities for transmission. So there seems to be this sort of pattern, and then other animals that seem to get it in Australia, it seems like they maybe get exposed through those spillover. And so there's sort of evidence that a lot of these macropods and other marsupials are potentially susceptible, but just don't ecologically get exposed. Whereas devils are probably the true exception, where they actually quite like using wombat burrows. I mean, why dig your own den when you can go use a wombat? They've done it for you. But we've never seen mange in those. And I wish I knew the answer to that one. It's a vexing one.
Well, that's really interesting. I was thinking about it, and I was thinking, well, actually, devils are not regarded as being very friendly, so that wouldn't be the contact. But burrows, I guess, a good source of transmission.
Yeah. I just want to say, all this reputation that devils have for being quite nasty. If you ever catch a wild devil, their instinct is to freeze. So all the researchers who work on wild devils just have them unanesthetised with like a bit of bandage across their eyes, and the devil just sits there like this and doesn't move. They can just have it laying on its back while they work on it. It's amazing.
Very cute, very cute. Okay, thank you very much. So on now to another question, which is puzzling people, and that is, why is this disease not seen more commonly in other abundant Australian wildlife, such as the kangaroo, for instance?
Yeah, I think I might have answered that by rabbiting on about some of my other ones. So I think it's probably more about ecological exposure, because they don't tend to hang out environments where the mite survives for so long. So we occasionally see it in swamp wallabies, but you almost never see it in the marsupials that hang out in more sort of drier sort of environments. It's been seen in agile wallabies very rarely, but I think it's just the opportunities for them to get exposed are very, very few.
That's so interesting, isn't it? Because it seems from what you're saying that environment and spread through close contact with the environment is so important. And so a big animal like a kangaroo is not going to go into any of those burrows and so on. So presumably hopping around, as we imagine they do, the opportunity would not be there. And of course, it's not as though they're having their young ones in sort of suckling in small environments, because they're doing that in the pouch.
That's correct. Yep.
Excellent. So that's so interesting. So we have talked about this to some extent, but there's another question which is really saying, okay, so transmission seems to be occurring through the environment, but are there other mechanisms? I mean, we've talked about dogs, for instance, and domestic animals. What about other, things like the marsupial mouse, for instance, which I know about almost nothing at all, but I'm just wondering whether other animals that we don't see so often could be involved in transmission.
Yeah, mange has not been recorded a lot in rodents, interestingly. Around the world it hasn't been recorded. I've recently had a student who's been trying to look at the different kinds of transmission of Sarcoptes that supports sustained transmission. And we kind of see these sort of interesting patterns where you get direct transmission predominates in some species, and they tend to be your like ungulate type species, like your ibex and your chamois in Europe. That's quite common that they really have sustained direct transmission, and that can have quite big population implications. You've got your environmental transmission, which we think is almost entirely environmental for wombats, and happens when they sort of asynchronous. So wombats like to move burrows, so they kind of shift house every sort of 4 to 10 days and go to a different burrow, and another one will potentially come into one that they were using. And so we think it's this sort of asynchronous burrow sharing that leads to transmission there. And black bears in North America look like potentially environmental transmission is the general consensus among the research community. And then we see sort of in canids that it's sort of den-using social species probably have a bit of a combination of both. So you see that on wolves and coyotes and foxes. that support sarcoptic mange that way. So I think those sort of, I guess, two and a combination of the two transmission sort of modes that go on. But for whatever reason, rodents don't seem to be reported with it as commonly.
Interesting. Okay, so this is a major problem. It's affecting a wide variety of different environments and animals. So what about its control? Because not just in wombats, but also in other Australian wildlife. What are the prospects there? What are the opportunities?
Yeah, I mean, I guess most people know that you can control sarcoptes using parasiticides, common ones being cydectin, ivermectin, moxidectin, I guess I should say. And people, it's actually quite a big issue here in Australia, where there's a lot of people who have no sort of scientific or veterinary training, who are very passionate about animals like wombats and actually actively go out and treat them for sarcoptic mange. And there's been some pharmacokinetic studies done with moxidectin where it's been shown that it lasts for about a week in their system before they metabolize it. So therefore you're having to try and treat a wombat every week for programs up to about 15 weeks. So we think the mites can survive down their burrows for at least 3 weeks, which is pretty hard to do. They're pretty uncooperative patients. But we've recently been trialling the use of Fluorolana or Bravecto for use on wombats and having really promising results with that, suggesting that a single treatment, kind of a dog equivalent weight, leads to protection for between 1 month and possibly greater than 3. And that seems to have worked quite well. So it could really sort of revolutionise some of the capacity to manage the disease in their populations here. The sort of the next step is better delivery of it in the field, because at the moment the main way that people deliver it is either chew to dogs, which doesn't really work for wombats, but or as a spot-on solution. And so we're working on ways to sort of improve capacity in that area. And I think there's good prospects. So we've done a bunch of modelling with the population that we're working on to suggest that if we go out and just try and treat every 1 to 2 months for just individuals that are showing clinical signs, observational signs of disease, we might be able to lead to certainly localised disease depression, possibly localised eradication. And we're actually testing that in the field at the moment.
Wonderful. I really enjoyed your lecture on this, where you touched on that, and I thought that the mechanisms you're using were really quite innovative and interesting, and I think there must be huge scope there. And the isoxazolines are so powerful and so long persistent in the environment. I worry a bit because we're using these antiparasitics so much in the world, in Europe. There's a major problem. For instance, I used to be able to drive from London to Birmingham, take me an hour and a half perhaps on the motorway, and the windscreen would be covered with dead flies in the summer. Last summer I drove and not a single fly died on the windscreen. We seem to be, I worry about widespread use of very potent and long-lasting ectoparasiticides. Are you seeing any impact of that in Australia?
Yeah, it's something I really worry about a lot as well. And it's partly motivates actually why we're looking at these sorts of things. So there has been some reports of ivermectin resistance in sarcoptes among Aboriginal and dog communities up in Northern Australia, where it's more a public health issue than it is a wildlife health issue. And then we also have some of these sort of community groups who treat wombats across southeastern Australia. And some of them use very, very large doses of moxidectin. They'll use, so where the sort of recommended sort of dose regimes are in the area of sort of 1 to 5 mils per 10 kilos of moxidectin, or cydectin, they're using in the order of sort of 200 mils. So huge volumes, admittedly on an individual basis, but potentially quite large volumes going into the environment with all the sort of potentially negative effects of that. So that's something that we're really concerned about. And we're really trying to sort of find ways of less chemicals going into the environment. It's sort of an additional motivating factor.
Right, excellent. Okay, we've just got a little time left, so I wanted to move on to a couple of other questions that we have here. The first one is on exudative dermatitis, which I didn't realize what a problem this was amongst possums. Can you tell us something about the pathogenesis of this and what approaches are being used for its control?
Yeah, it's really a really interesting disease, and there's so much to learn about this as well. And it's often coupled with another condition that's called rump wear in possums. So brush-tail possums and mountain pygmy possums, and we're starting to see it here in Tasmania and in ringtail possums as well, all often get this sort of like worn patches on their rump. And when that happens, they tend to sometimes it will get so bad that they will get sort of these ulcerations on the actual skin surface itself, and it'll wear that thin. Other times it seems to be more that it's sort of breakages in the hair, just structure itself and thinning of that. And the sort of etiology of that's been relatively unknown. There's been a few investigations into that. One of them suggests that a mite that the possums have may be a causal factor, and I think there's I think it was a Staphylococcus recently, I think that you even pointed out to me recently, David, that has recently been associated with that. So there's a reasonable amount still unknown about that. The actual exudative dermatitis can sometimes spread to the face and other areas of the epidermis, and possums do seem to be able to recover from it, but broad-scale antibiotics also work quite well.
That's really interesting. I've seen some of the pictures of these poor animals, and they really get severe disease. It looks horrendous. So, fine. And then we have one final question. I think we've just got enough time for one final question. And this is relating to work which you've done with chytridiomycosis. So we're seeing this huge problem with it worldwide, with populations being wiped out. Can you tell us about the distribution of this disease in Australia, and what do you think can be done to prevent it from becoming a really major issue?
Well, it's it's unquestionably the most significant wildlife disease in the world. It's associated with declines of over 500 species and likely extinctions of many in Australia. It's been associated with declines of over 40 species and probable extinctions of 6, of which some of the most well-known examples include the gastric fruiting frog that hasn't been seen for many years now. And its distribution really extends through the sort of more temperate sort of wet areas, so right along the east coast of Australia up into Queensland and in sort of southwestern Western Australia and Tasmania as well. And there's really variable dynamics in different amphibian species. So in some it seems to persist at low levels, and some it's not persisting as well, and some it does cause dramatic declines. And there's some frog species that are under very intensive conservation efforts, such as the corroboree frog, which involves a combination of captive breeding and there's research going into using things like gene drives to try and essentially enable them to exhibit some sort of resistance to it. But there isn't really any one good solution for sort of population management of this disease anywhere. Some of the best solutions have been more or less draining wetlands, spraying a lot of antifungal agents and then refilling them in very limited cases. So it's an exceptionally challenging disease to manage.
Wow, what a challenge. Gosh, sadly we're running out of time. That's absolutely fascinating. Gosh, it really makes me wish I could come out there and see some of these animals myself, and I'm afraid not until we get rid of this pandemic. So,
well, it'd be great to have you out here.
Scott, thank you so much for that. I mean, so fascinating, and actually made me think about so many other diseases. And of course, these skin problems are so varied. And wow, who would have thought about a skin problem or skin problems wiping out hundreds of species of animal? Wow. that's something to think about. So thank you very much, and thank you to all of the delegates who have joined us. I hope you've enjoyed as much as I have. Wow, we could have gone on for another hour. May I remind you that the next question and answer event will be on Monday the 12th, where we have Mike Lappin talking about fleas. And as far as this session is concerned, it's recorded, so you can get it on the Facebook page, which you can reach in the networking lounge, and you can also, it will also be advertised by Webinar Vet, so you can log on to that. Please tell your friends about it. I think they're going to be fascinated by this story. There's so much more we could have done, but there we go. We've been beaten by the time. So Scott, great to meet you. Have a lovely day. And everyone else, stay safe and enjoy the rest of the Congress. We still have until the 21st of the month. Thank you very much.
Thanks so much, David.